Today we're talking to Jacopo Buongiorno, Professor in Nuclear Science and Engineering at MIT. We're at ICAP 2019, which is being held at Juan-les-Pins on the French Côte d'Azur. Jacopo has some ideas for a nuclear future for Australia, so perhaps you'd like to enlighten us.
Yes, thank you, Robert, for inviting me to this nice video. So I'm Jacopo Buongiorno. I'm a professor of nuclear science and engineering at MIT. I recently led a large team of faculty and students to conduct a study on the future prospects of nuclear in a low-carbon world, and generated some findings that I think are relevant also to Australia. The first and most important is that the future of nuclear is bright if its potential contribution to decarbonization of the power sector is properly recognized and valued. What we found is that as the world, and Australia in particular, seek to reduce carbon emissions in their electricity sector, having a dispatchable low-carbon energy source such as nuclear allows you to reach the decarbonization target with an overall system cost which is much lower than if you excluded nuclear. That is because if you exclude nuclear from your energy sector, particularly your power sector, then the only technologies that you have available to decarbonize that sector are the intermittent renewables and the storage that goes with it. The implication in those scenarios is that you end up overbuild the capacity of solar and wind because they don't always generate the electricity that is needed, as well as the storage that is required to sort of fill the gaps created by that intermittency. If, on the other end, you maintain a dispatchable, a controllable energy source such as nuclear, then the overall capacity that has to be developed to decarbonize the power sector is much reduced, and therefore the overall cost of the electricity sector and ultimately the overall cost of electricity to ratepayers is significantly reduced. That's the first main finding. The second finding is that the business opportunity for nuclear increases exponentially if its cost actually is reduced. So it's all about cost, given the objective of decarbonization. And we spend in our study a great deal of time trying to understand where the cost of new nuclear power plants really is. Everybody knows that it's the plant itself that costs money, not as much the fuel or the operation and maintenance. But exactly what is within a nuclear power plant that is so expensive. And so we found that contrary to I would say a common belief, particularly within the nuclear engineering community, the direct cost of the reactor equipment, the vessel, the piping, the steam generators, the turbines, as well as the so-called Balsa plant, is actually not that large. Maybe accounts for as much as 25-30% of the total cost. The rest of the cost, the bulk of the cost, is actually in installation and indirect costs. So all the labor and materials such as concrete, including rebar, reinforcement, and so on, that are necessary to prepare the site, to excavate the site, create the civil structures, all of that, and the engineering that takes place upstream, all the time for the engineers and the technicians to basically create the detailed design of the power plant, bear most of the cost. So this is an important finding because the implication is that we may not necessarily need new reactor designs per se. What we need is a shift in the paradigm by which we actually build, construct, deliver these nuclear power plants. This could be important for Australia as well, because if Australia decides that nuclear can play a role in its energy mix in the future, it has to play a role that is cost effective and cost competitive. And so the findings and recommendations that we generated would apply to the specific projects in Australia. I guess the third important message is, which has been well known about nuclear, is that it does provide, in addition to a potentially very important contribution to decarbonization, a almost inexhaustible energy source. The fuel is plentiful, and the great news for Australia is that majority actually of the world's reserve of uranium are in Australia. It's already big business. It could become even bigger if the global fleet of nuclear power plants grows over the next few years.
Do you intend to come to Australia and discuss these ideas in the future?
Well, Robert, it's funny you should ask this because I am planning to actually come to Australia in January. I've been there a couple of times, partly for business, partly for pleasure. I had wonderful experiences and I look forward to visiting again in January. And I hope we can set up meetings with other scientists as well as decision makers and also policymakers within Australia that are trying to decide what the cleanest, most effective and cost competitive energy mix for Australia is going to be over the next 30 years. And I hope what the work we've done at MIT can help them make those decisions wisely.
I look forward to that. And maybe we can share in some nice Australian wine.
Absolutely. And maybe a nice trip to the Outback as well.
For sure.
Thanks so much.
Thank you.
Thank you, Robert.